Hello everyone, today I'm going to be discussing net present value, or NPV for short. I'll be referencing it as NPV for the rest of the video. So NPV is the difference between the present value of future cash inflows and outflows over a specific period of time. So the purpose of calculating NPV is to see if a project will be profitable. And if it is profitable, by how much money it will be expected to make in terms of present value dollars. So if NPV turns out to be positive after we go through the equation, then the project will most likely be profitable. And then it's the opposite. If it turns out to be negative, it will most likely lose money, in which case, if NPV does turn out to be negative for a project, the person who's running the project should no longer run that project or make some changes until NPV turns out to be positive. So going through the equation of what NPV is, I wrote it down here, and then I wrote the variables over here explaining what each of these denotes. It kind of looks a little daunting, but it's pretty easy if we break it down and then use an example, which I will at the end of the video, but kind of going through each step. So the first part of NPV is C1, which just means the cash flow of the first period divided by 1 plus R. So R is the discount rate. Basically, that means it's whatever rate that the cost of money is at that time. So if it's an interest rate on a loan, say it's like 10% to take out a loan, the discount rate would be 10% in this equation, so that R would be right around 10% or 0.1. And then we do the same for this section, which is just the cash flow of the second period divided by 1 plus R squared, so to the power of 2, since it is the second period. And we do that for however many periods we're looking at this project for, until we get to the end, which is Cn, which is the cash flow of whatever the last period is, divided by 1 plus R to the power of n, to the power of whatever period that last period comes out to be. Then at the end, we have to subtract our initial investment, which is CO. So probably a lot of that doesn't make too much sense, but it's a lot easier when we actually have an example. So I just made a very easy example at the end here of a lemonade stand. So say we buy a lemonade stand permit for $500. So since we're buying that permit, that's our initial investment. So CO is 500. And then the permit lasts for 3 years. So our N value is 3 years or 3 periods. And then we expect net cash flows to be $200 per year. So that is our cash flow. Our C value is 200. And then we have the discount rate, 10%. So we could take out a loan. That loan would cost us 10% currently. So that is why our discount rate is 10%. And then just going through the NPV equation, so basically just plugging in the numbers from this, cash flow is 200 divided by 1 plus the discount rate, which is that 0.1 there, and we get 182. And by the way, I rounded these numbers to the nearest dollar just to make it easier. And then we go to our second period, which is still the $200 in the numerator, divided by 1 plus 0.1, and this one is to the power of 2 since it is our second period, comes out to be 165. And then our final period, since it's 3 periods in total, is 200 divided by the 1 plus 0.1 to the power of 3 for that third period there, which is 150. Then at the end, we do have to subtract that $500 of our initial investment. And then when we add them all up and subtract that 500, we actually get a negative $3 for our NPV. So like I said before, if NPV is negative, then the project is not worth taking. Most likely it will create a loss, basically. So if it's positive, if the cash flows turned out to be like $250 in the numerator there, then NPV would most likely be positive, in which case it would be profitable to take this project. But since this number does come out to be negative, then this is not a good project to pursue. So yeah, this is a very basic example, and in the real world, a lot of these numbers can change. Like the cash flows would most likely not be the same year over year. There would be probably a lot bigger time period as well. So many different years and many different time periods. Initial investment would be a lot higher usually. So this is just a very basic example, but it's really just to explain how NPV works in a scenario that could be easily explained. Anyways, thank you for watching, and I hope you enjoyed.